Hello everybody, we're getting ready to do lesson 5.6 of Geometry 1 Math Part 1. 5.6 is angle bisectors and perpendicular bisectors. We have a 34-point skill sheet. We have 0 points of a notebook entry today. And teachers, here's the bell work for today. Give your students 5 minutes, find the value of x, given that P is perpendicular to Q. Then down here in the diagram, suppose that AD is congruent to CB and angle BCA is congruent to DAC. Which triangles can you use to prove that angle EBA is congruent to EDC? So that's going to take some time to untangle those. Give your students 6 minutes to do this. Okay, welcome back. And our solutions for today's bell work is up here for number 1. We have 4x plus 1 plus 37 degrees equals 90 degrees, and then we solve for our 90 degrees here on the left side, and we get x equals 13 in this case here, 52, 53. So x would equal 13, and then number 2 would be a triangle ABC, so it'd be triangle ABC in angle CDA here. CDA would be congruent to show that you can prove EBA. EBA is congruent to EDC. EDC. So you have to separate those triangles, and then that will be more of an apparent kind of method of proving this here. Okay, the distance from a point to a line is measured by the length of a perpendicular segment from the point to the line. When a point is the same distance from one line as it is from another line, the point is equidistant from the two lines. And we have a situation here where this point here is equidistant from the bike path and equidistant to the jogging path, 15 feet here, and these are perpendiculars here from the two different paths to the point in the center, which would be the foundation. Theorem 5.3 of a point is on a bisector of an angle. Here's bisector, here's a bisector. Then is equidistant from the two sides of the angle. So here's a point here, it will be equidistant from there and equidistant from there. This is a bisector here, and that proves that these lengths of these lines are the same. Symbols of measure of angle 1 equals measure angle 2, then BC is congruent to BD. So BC is congruent to BD, and we got the same hash marks there. Students, in your own words, define distance from a point to a line and equidistant. Okay, example 1, use the angle bisector theorem. Prove that triangle TWU is congruent to triangle VWU. So these two triangles here, we want to prove that they are congruent. So given line UW bisects angle TUV, here, this line here bisects TUV, and triangle UTW and UVW are right triangles. We have this right angle here in this triangle, same thing over here. UVW would be congruent to what they call it, UTW. Statements and reasons. So UW bisects TUV. We got that. Here's UW. Triangle UTW, UVW are right triangles. Yeah, we got those there. And then line WU is congruent to line WU. Yeah, it sure enough is. And then line WV would be congruent to WT here, angle bisector theorem. We already went over that. Therefore, triangle TWU is congruent to VWU, hypotenuse leg congruent. So we have our hypotenuse here, which they both share, and we have a leg here that they both share. So that means that they are congruent by that. Okay, our first guided practice here, students, teachers, give your students about 5 minutes, 6 minutes to solve these two questions here. Use the information in the diagram to find a measure of EF here, of EF. And then down here, find QR. So we need to find QR here. We need to find QR. Use the information in the diagram to find this measure here. Okay, coming back, here are our solutions. EF equals FG. Find EF. So EF here would equal FG because of the previous theorem about finding the point in the middle, or rather that's on an angle bisector here, which would be that point there. So x plus 1 equals 2x minus 1. These equal each other, don't we? So we have to solve for x, and we get x plus 1. We get EF equals 3 is what we do. And then we solve for x. 1 equals x minus 1. 1 plus 1 equals x minus 1 plus 1. 2 equals x. And then we plug it back in to find EF once we know what our x is. And then 2 plus 1 would equal 3 here. And then down here, QR equals QP. We have the same thing here. QR equals QP here. And then so we solve for x, 4 equals x, and we plug that back in to find the length of QR here. And we get 12 plus 8 would equal 20. We have a right triangle, and we use the information to find a diagram here. So they're both right angles here. They have a leg, so we have a hypotenuse leg situation going here. We know these both equal each other. We just need to find the length of QR here. And that was part 1 of lesson 5.6. Part 2, part 3 available here. Thank you.